Good afternoon, this is Kavipriya, Assistant Professor, EC Department. I am going to discuss about the topic Boolean postulates and law from the subject Digital Electronics. So first, what is this Boolean algebra and theorems? So Boolean algebra is a structure that is defined on a two set of elements, which is nothing but zeros and ones, and it uses two binary operators, addition and multiplication. The postulates are the basic algebraic structure that require no proof. Closure is a set that has a two operator, multiplication and addition, and the result of the operation will be either 1 or it can be a 0. And next is what are all the key laws that is involved in the Boolean algebra. First one is a commutativity. So the commutativity implies the order of the operands does not affect the result. For example, a plus b is equal to b plus a. Similarly, a dot b is equal to b dot a. So even if we change the order of the operands, there won't be any change in the result. And next is the associativity. Associativity implies that even if we change the grouping of the operands, there won't be any change in the result. For example, a plus b plus c is equal to a plus b plus c. So both the left hand side will be equal to the right hand side. Here we have changed the grouping of the operands. So even if we change the grouping of the operands, there won't be any change in the result. A dot b dot c is equal to a dot b dot c. And next is the distributive property. The multiplication will be distributes over the addition. Similarly, addition will be distributes over the multiplication. So a plus b plus c is equal to a plus b plus b plus c. Similarly, a dot b plus c is equal to a dot b plus a dot c. And next is the identity law. This is also one of the laws in the Boolean postulates. According to identity law, a variable that is AND with the 1 will always be equal to the particular variable. Similarly, a variable that ORed with 0 will be equal to the same variable. And next is the annulment law. According to annulment law, a variable that is odd with the 0 will be equal to the 0. And similarly, a variable that will be odd with 1 will be equal to the 1. And next is the idempotent law. According to idempotent law, a variable that is odd with the same variable will be equal to the same variable, and variable that is ANDed with the same variable will always be equal to the same variable. And next is a complement law. If a variable that is ANDed with the complement of the variable will be equal to 0. A variable that is odd with the complement of the variable will be equal to the 1. And next is a commutative law. According to commutative law, the order in which two variables ANDed are makes no difference. A dot b is equal to b dot a. Similarly, the order in which two variables ORed makes no difference. A plus b is equal to b plus c. And next is the associative law. It allows to remove the brackets from the expression. It has two types. One is the OR associative and another is the AND associative. OR associative law is one. A plus B plus C is equal to A plus B plus C, which is equal to A plus B plus C. So even we can remove the brackets according from the expression. And similarly, AND associative law, A into B dot C is equal to A into A dot B into C, which is equal to A dot B dot C. And next is the activity, which is a riddle based on the Boolean postulates. If I have two inputs A and B, my output is 1 only if both the inputs are 1. Otherwise, my output is 0. What Boolean law am I? Which is nothing but it is an AND law. I am a complex expression, long and quite grand, with multiple terms. I span the land, but apply the laws and reduce my size. What property of Boolean algebra help me rise from many gates to fewer and save the design price? We can use laws like distributive law, absorption law, and idempotent law for simplifying the Boolean expression. And next is I am a principle that shows two sides, both true or false. One side uses and other side uses or, but the opposites hold the same logical code. What theorem am I? It is nothing but it is a De Morgan's theorem. And next is a distributive law. It permits the multiplying or factors of a variable. A into B plus C is equal to A dot B plus A dot C. and distributive is 1. A plus B dot C is equal to A plus B dot A dot C. And next is a double negation law. The inversion of a term twice will result in a same term. So if we take a double inversion for a term, it will be equal to the same term. So here double dash is nothing but it is a double inversion. And next is a De Morgan's law. It works on the concept of duality. It helps in solving the algebraic problems in digital electronics. According to De Morgan's law, A dot B the whole dash is equal to A dash plus B dash. So the negation of conjunction is the disjunction of the negations. So first, in left hand side of the equation, here the negation of the conjunction has been taken place, and right side disjunction of the negation takes place. So both are same, and other one is nothing but A plus B the whole dash is equal to A dash B dash. So negation of disjunction is the conjunction of the negation. So the complement of sum of two variables is equal to the product of complement of each and every variable. And next is the assessment. In Boolean algebra, the OR operation is performed by which property? It is done by associative, commutative and distributive. According to Boolean law, A plus B is equal to A plus 1 is equal to 1. The involution of the A is equal to A itself. So that's all about the Boolean law, Boolean postulates, and also we have discussed about the various laws involved in Boolean algebra, and we have discussed about the De Morgan's theorem. Thank you.